Alright, so before we start section 8.4, I'd like to just remind you of a few things that are going to be very important for the solving portion of this. So just remember that we have so far talked about how log functions have transformations. So they have an a, a b, an h, and a k that can be transformed to them. Also remember that our graph of a log function looks like this red graph right here. It has a vertical asymptote associated with it, and then it's either it's a inverse, that's the word I'm looking for, the inverse of an exponential function. So remember that exponentials and log functions are inverses, which means they undo each other. Also remember that log and exponentials can be switched back and forth between the forms, where the bases are the same here, but the exponent is what your log is equal to. Finally, what we just did in section 8.3 was we talked about the laws of logs. So how if you're multiplying, you can split them by adding. If you're dividing, you can split them by subtracting. And if you have a power, or say p, that power can be moved to the front and it becomes multiplying. So that's so far what we've done with our chapter on logs. So please write these rules down. All we're saying here is that if you have the same log on both sides, you can get rid of the logs and just deal with your other numbers. Or if you have just two sides of an equation, you can add the logs in, whichever that case is going to need to help you out. So here is then our first example. It says solve. We have log 2x minus 1 with a base 6 equals log 11 with a base 6. You should notice that you have log base 6 on both sides. So that means that 2x minus 1 must be equal to 11. Because again, the log base 6 is the same on both sides, so I don't need to deal with that. I can just say that 2x minus 1 must be equal to 11. Now it's pretty easy from here. We can add our 1 over, so we get 2x equals 12, and divide out our 2, so x equals 6. So x equals 6. Now, as with all equations, what do we need to do? Check. We need to do a check on this, because you can have extraneous roots. So we're going to have to check that 6 works. When you go through your check, you should notice that 6 does work. Alright, so for this one, we have a log on both sides, but there's actually another number on both sides, or on the one side as well. There's a 1 over there. So we can't just remove the log, because there's no log with that 1. So our strategy here is I'm going to try to combine the logs. So since this log is adding, I'm going to subtract log x plus 1 to the other side of the equation. So what I end up with here is log of 8x plus 4 subtract log of x plus 1, and that's going to equal 1. Now we have some laws that we learned. When I am subtracting two logs, how can I combine them? Dividing, right. So let's subtract, or let's divide those. So we're going to get log of 8x plus 4 divided by x plus 1, and that equals 1. So now in this question we have log 8x plus 4 over x plus 1 equals 1. So here we have to change it to exponential form. My base for this is base 10. So I'm going to go 10 to the power of 1 equals 8x plus 4 divided by x plus 1. So now let's multiply out that x plus 1 to both sides. And I'm just going to come up here so I have more room. So we have 10 times x plus 1 equals 8x plus 4. Now this is just a linear equation we can solve. Let's put the 10 into the brackets to get 10x plus 10 equals 8x plus 4. And then we'll move things around. So I'm going to subtract my 8x to be over by the 10x, and subtract my 10 to be over by that 4. So we'll on one side be left with 2x, and on the other side be left with negative 6. So when I divide out the 2, we're left with negative 3 for our answer, negative 3. So when you go through the check, you'll notice that the check does not work, because you can't have a negative behind the log. Again, if you type in log of negative 20, you get an error on your calculator. You can't have 10 to a power that gives you a negative number, so it does not work. That tells me that my answer is extraneous. So x is minus 3 is not an answer. There's actually no solution to this problem. Alright, so let's take a look at this question. Here we have log of x plus 3 squared with a base 2 equals 4. So when we have x plus 3 squared, what that means is that we have to FOIL that out. So we end up getting x plus 3 times x plus 3, that's going to equal 4. So when we FOIL it, we get x squared plus 6x plus 9. Again, we have multiplied the x plus 3 times the x plus 3 to get x squared plus 6x plus 9. Now, just like the previous question, this just equals a number. So, how do we change it so that there's no log anymore?
Exponential form.
Exponential form, right. So our base is 2. So we go 2 to the power of 4, and that's going to equal x squared plus 6x plus 9. Good. 2 to the power of 4 is just 16. And now how do you solve a quadratic? You have to factor it, but first we need everything on one side of the equation. So it has to equal to 0, yes. So I'm going to move that 16 over to combine with the 9. So we get 0 equals x squared plus 6x minus 7. And then we can factor.
And then plug them in.
Once we've factored, we get x plus 7 and x minus 1, which means one of our answers is at negative 7, and the other answer is at positive 1. Then we do have to go through and check our answers. And just for time on our video, the checks both work when you plug them in. So then both of these are going to be solutions. So it is possible to have 2 solutions. All right, so this is example 2. We're solving, but these ones look different. What form are these ones all in? Exponential, right. So to solve an exponential where you can't get it to the same base, remember when we did this before, we'd break them both to the same base and then look at the powers? But I can't put 4 and 605 as the same base. So instead of doing that, we can do the inverse of that, which is logs. All I have to do is put a log in front of both. And what's the easiest base of a log you know?
10.
Base 10, because your calculator can calculate it, right? So I'm going to put a log base 10 in front of both sides of the equation. Now here's why this is helpful. Because we have a property that says that your power of x can move to the front and become multiplying, right? That was one of our log laws. So now we have x times log 4 equals log of 605, and those are both base 10. How do I get the x by itself? Divide out the log 4, right? Divide out the log 4, and you guys, your calculators can do this. You should get x is 4.62, and when you check it, it does work to give approximately 605. Okay, so that was our part A. Let's look to part B. Part B is very similar, but there's an extra 8 out front. We don't want to deal with that 8, so how can I remove the 8? Okay, we divide it to the other side. Just divide out the 8 to the other side. So we'll get 3 to the power of 2x equals 71. This is 568 divided by 8 is 71. Now I have it to look just like the question before. Again, 3 and 71, we can't put them to the same base. So instead, we'll add a log to the front of each. And I like to just kind of squeeze them in there instead of writing it out again. So we get log 3 to the power of 2x equals log 71. What can I do with that 2x? Bring it to the front, exactly. So we get 2x times log 3 equals log 71. Okay. How do I get rid of the log 3? Divide it out, exactly.
Divide by log 3.
Yep, because these two things are being multiplied together. The inverse of multiplying is dividing, so I'm just going to divide it out. So log 71 divided by log 3 should give us approximately 3.88. And then we'll finish off by dividing out that front 2 to get an answer of 1.94. So in this more complicated question, we're again going to start by putting the log in front of both. The difference here is that we have 2 exponents, 1 on each side. That's okay, they still go to the front of the log. So we'll end up with 2x subtract 1 times log 4, and that equals x plus 2 times log 3. So again, I'm just bringing those powers to the front. Now at this point, I think the easiest thing would just be to get some decimal numbers, okay? You know log 4, you just have to calculate it. You also know log 3, you just have to calculate it. Again, they're ugly decimal numbers, but they still do work with the equation. So when you type in log 4, what do you get? So now once we have the log 4 calculated to be 0.6 and the log 3 calculated to be 0.48, we're just going to multiply that 0.6 in. So 0.6 times 2x is 1.2x, subtract 0.6, and then on this side, again, I'm going to multiply that 0.48 in, so we get 0.48x plus 0.96. And again, this is now just linear, so we're going to combine our x's on one side and our numbers on the other. So I'm going to subtract the 0.48x, and then I'm going to add that 0.6 over to be with the 0.96. Good, then we're just going to divide out that 0.72. So we'll end up with x equals approximately 2.17. Again, that's approximate, it is an estimate, but if you check, it will work approximately. So that's as hard as these examples get, okay? Again, putting the log in front makes things a lot easier. The textbook assignment for today is page 412, and you just have to choose 2 letters from each.